She wore gloves to stop the bleeding, not for protection. It was far too late for that. The damage accumulated for 25 years, quietly, invisibly, one cellular catastrophe at a time. The gloves were practical. Without them, her fingers would bleed onto the podium during lectures. That was untidy, unprofessional, unacceptable. So, she wore gloves. Her vision was going, had been for years. For eye operations, doctors not optimistic about a fifth. Her bones ached in ways medicine in 1923 didn't have language for yet. Fatigue sleep couldn't touch. Exhaustion living below muscle and bone, cellular deep. On her desk, under those gloved hands, were notes for her next experiment. What's extraordinary about Marie Curie isn't the 2 Nobel Prizes, or the discoveries, not the radioactivity research that reshaped medicine, energy, and warfare simultaneously. What's extraordinary is this: she knew exactly what was happening to her body, and why. No mystery, no cruel irony of ignorance. She was the world's foremost expert on radiation. She spent a quarter-century studying how it damaged living tissue. She understood it, and it was killing her anyway. To understand why she kept working, we must know who she was before the laboratory. Maria Skłodowska was born in Warsaw in 1867. Poland had been carved off the map. Russians banned Polish education. Teaching Polish history was an act of resistance. Her father, a physics teacher, lost his position for refusing to collaborate. She learned early that the world could take official things, language, country, father's job. What it couldn't take was what you carried inside your head. Knowledge was theft-proof. This idea became the organizing principle of her entire life. She worked as a governess for years to fund her sister's medical education in Paris. She was patient in ways that would have broken most people. She arrived in Paris in 1891, 23 years old, registered at the Sorbonne as Marie, enrolled in physics, finished first in her degree, then did it again in mathematics, finishing second. Not trying to make history, but finish her thesis. She met Pierre Curie in 1894. He was an established physicist, brilliant, eccentric, famously uninterested in money or recognition. They had a revolutionary partnership. He treated her work as equal to his own. They married in 1895, bought matching bicycles, spent their honeymoon touring the countryside. A charming detail. Remember it, because the next part isn't charming at all. The laboratory was a shed, not a metaphor. A literal wooden shed. A German chemist described it as a cross between a stable and a potato cellar. It leaked. In winter, experiments stopped because equipment froze. Ventilation was non-existent. This is where they discovered radium. Marie's hypothesis, radioactivity was an atomic property, not a chemical reaction, not a surface phenomenon, intrinsic to the atom itself. Most scientists thought she was wrong. To prove it, she needed to isolate the source. She and Pierre spent for years processing 1 ton of uranium ore by hand, breathing fumes, carrying residue in bare hands. Radiation exposure wasn't understood, like panning for gold in a toxic river, not knowing the river is toxic, and the gold is invisible. In July 1898, they announced polonium, named for Poland. In December, radium. The scientific community was stunned. The popular press was fascinated. Radium glowed. Literally glowed faint blue-green light, visible in the dark. It seemed almost magical. That glow was commercially exploited. Radium in face creams, toothpaste, drinking water. The world decided radiation was miraculous. Marie watched with considerable discomfort. She knew the science, what it did to tissue, but correcting the public narrative was hard. Then something happened that changed everything. Pierre stepped off a curb, struck by a horse-drawn wagon. He died almost instantly. He was 46. Marie was 38. She had 2 daughters. The younger, Thea, was barely a year old. The Sorbonne offered her Pierre's professorship, a practical solution. She was the only one qualified to teach his courses. She accepted. November 5, 1906. She walked into a packed lecture hall. She began exactly where Pierre's last lecture had ended, not from the beginning. The room went silent in a way people described for the rest of their lives. But here's where the story gets complicated. Symptoms were accumulating. She began to understand scientifically, rigorously what they meant. Finger damage, bone pain, fatigue, cataracts. By her second Nobel in 1911, something was wrong. She didn't stop. This wasn't denial. Marie Curie was making a calculation, the same rigorous, unsentimental calculation she applied to everything, and she reached a conclusion difficult to argue with. The work mattered more, not because she didn't value her life, but because she valued what the work could produce. Radiation research showed profound implications for cancer treatment. Mobile X-ray units she drove to battlefields during we saved hundreds of thousands of lives. Every month of research was another breakthrough, another diagnostic tool, another life extended. She was spending her time to buy other people's time. She knew the exchange rate. She kept paying. By spring 1934, she couldn't ignore it. Anemia became severe. Temperature spiked and dropped. Admitted to San Lemos Sanatorium. Doctors were puzzled. She didn't have tuberculosis. Her lungs were clear. The bone marrow was the problem. Blood wasn't produced correctly. Cells malformed. They didn't have the language for it. Radiation-induced aplastic anemia wasn't a clinical category. Marie Curie was dying of a disease that wouldn't be named until after her death. On July 4, 1934, she died. Death certificate: aplastic anemia. Cause: prolonged exposure to radiation. She was 66 years old. Pierre had been dead for 28 years. She worked every one of those years. Built an institute, trained physicists, drove through war zones, won a second Nobel, refused to be erased by scandal, exclusion, grief, or pain. She had not slowed down. She had chosen not to. Marie Curie's notebooks are still there in Paris today. Her handwriting, calculations. You can request to see them, but first, you'll sign a liability waiver, and you'll put on protective equipment, because those notebooks are still radioactive, not dangerously so in brief exposure, but measurably, detectably. The radiation hasn't gone anywhere. It doesn't go anywhere on a human timescale. Those notebooks will still be radioactive in the year 3524. Her legacy is not abstract. It is physically, measurably present in the world. The substance she studied, the force she gave her body to understand, still radiates. Her notebooks are not a record of her work. They are her work, still emitting. She is, in a technical sense, still in the room. Here's the question her story leaves me with, and perhaps you too. We celebrate Marie Curie for her sacrifice. We frame her as someone who gave everything. That framing is true, but it's also convenient. It lets us admire the sacrifice without asking the harder question underneath it. What does it mean to fully understand the cost of what you're doing and choose it anyway? Not because you don't know better, not because you're brave in an uncomplicated way, but because you've run the numbers. You've done the calculation, and you've decided that what you're building is worth what you're spending. Most of us will never face a choice that stark. Weigh our survival against something so large. But her choice calmly, scientifically, without drama or regret says something about what a human being is capable of deciding. Her hands cracked and bled. She put on gloves. She kept writing.